Welcome back, ladies and gentlemen, and welcome to our newest unit. We are going to be talking about three-dimensional solids here. Now, for today, we're going to focus mostly on just vocabulary, naming what types of images these are, what specific names we'll give to them based on the kinds of shapes that make them up. But we're going to be talking about objects that you would actually be able to interact with in the real world, things that have actual height, width, length, depth, however it is you want to describe it. So, I know that you've seen a lot of these kinds of shapes before, maybe some of these words we've used already, but I do want to just make sure that we're very clear on what it all we're saying. So we're going to start with our vocabulary before we even describe what kind of shapes these are. Each of our 3D solids, no matter what kind of solid it is made up of faces. And we call a face of one of these surfaces just any one of the polygons, or maybe we'll get to some circles later, that make up any part, any full flat surface on one of these things. So imagine you've got a box. The top of the box is a face. The side of the box is a face. The bottom of the box is a face, and so on. And those faces can be of any shape. I've only highlighted rectangles so far, but this hexagon up here, that would be a face of that as well. Now, edges, we're talking about the segment that is the intersection of two faces. Basically, anywhere you see two of your shapes meet, this rectangle for the top, this rectangle for the side, meet at this edge. This triangle here and each of these rectangles, they meet at a single edge. Same thing with our hexagon. So edges are just line segments. So a face is a two-dimensional object, an edge is a line or a one-dimensional object, then you have a zero-dimensional object, our vertex. And vertex means just what it's meant for you guys in all of your different uses. Vertex is a point that is an intersection of three or more faces. Basically, a vertex is any of the corners that you'll see as you go around a shape like this. And depending on what kind of shape you're looking at, you've got some that have only a few vertices, and you've got some that have a whole bunch. So again, it'll just depend on what kind of picture we're looking at, what kind of drawing. But we'll be talking about faces, edges, and vertices in pretty much all of what we're going to be doing now. So today is going to be an introduction to just naming these things as well. So what kinds of shapes are we looking at? Now, I know for a fact that most of you know what this is. And maybe you've called it a box, but we're going to have a more specific name for it. Same thing with each of these things. This may look like a gold bar or something. I don't even know what you would call this, but I do know that each of these solids is an example of what we call a prism. Now, a prism is not just one of those things that you shine light through in a science class. A prism is any sort of 3D solid that's made up of the following properties. You have two parallel polygonal faces called the bases. So again, we've said that there are multiple faces to each of these shapes, but we need to find two faces that are parallel in order to find our bases. And I think the easiest place to look right now is going to be this. If I'm considering this kind of shape right here, and I'm looking for two faces, two solid flat surfaces of this shape that are parallel to one another, the only options I have right here are this triangle in the front and this triangle in the back. All of these other sides, these rectangles, they all touch one another. They can't be parallel if they touch, just like lines. So these would be the bases of this prism. And you'll notice, well, those aren't the only sides that we see for that prism. We also have our rectangles going along this way. You've got one going in the back. You've got one on the bottom. Because every prism, no matter what kind of base you have, will have rectangles that connect those two bases together. So for this shape in the middle, our two bases were the triangles, but each rectangle connects those two triangles together. Again, you guys can see the specific word that I've drawn there or written here. We call these the lateral faces. The lateral faces of a prism are just, not the bases. So for example, in this drawing over here, I see a bunch of rectangles going around the outside, but I also see two hexagons. Well, my lateral faces can only be rectangles, which means anything that's not a rectangle would have to be my base. So this would be a hexagon on the top and the bottom that form the bases of that prism. So what about this one on the left here, the box that you guys have seen so many times before? Well, funny story about that. If we want to know the bases of this box, most of you guys will go for the top and the bottom, just like you used to. Top, bottom, because bottom means base to you guys, and that's great. It's not the only set of bases we can pick. Let's say I'm looking at the left face of this prism and the right face of this prism. Let's check the properties. Two parallel polygonal faces called bases. Yeah, these two rectangles would be parallel to one another. The sum number of rectangular faces connecting the two bases. Is every other face of this prism a rectangle? Well, keep in mind, ladies and gentlemen, if you guys have been saying, oh, but this is a square up here. Well, all squares are rectangles. So, yeah. For a rectangular prism, the box that you guys have been seeing the most often, you can have whatever pair of bases you want. It can be top and bottom, it can be front and back, it can be left and right sides. And when we name these prisms, you'll notice I just said the words rectangular prism, because prisms are named based on the polygons that form their bases. And you guys can see where I've named all three of these things. This is a rectangular prism because whether you pick top and bottom, left or right or front and back, they're all rectangles. But for this shape in the middle, again, we said we have the two triangles that are parallel to one another. That means, yeah, we have a triangular prism. Here, the only shapes that aren't rectangles are hexagons, so this is our hexagonal prism. So, not so bad so far, I think. Again, you've seen a lot of these shapes in the real world. The nice thing about these is everything are straight lines. All of their faces are polygons. So, of course, we can't keep it that simple, right? We have to go on to something a little bit different. Now, cylinders I know you guys have seen a ton of in your lives, whether you've ever, had a can of soda or run out of paper towels. But a cylinder actually shares a lot of the same properties that a prism does. For example, we have two bases. Those two bases of a cylinder will always be circles. There is no hexagonal cylinder or triangular cylinder because they have to be circles. They're parallel to one another, though. Those two circles will never meet. They are level with one another. Think of, again, the top and the bottom of a can. And then you have a single lateral face, which when unwrapped forms a rectangle. And the best way that I can consider to explain to you guys how it is that the only remaining side of this cylinder is a rectangle, it might look like it in here, but what about in the real world? I'd say take a piece of paper and roll it into a tube, like you're in second grade and making a telescope with your piece of paper. Well, your paper is a rectangle, and when you roll it into a tube, you make a cylinder. So that's one way to remember exactly what kind of thing here. Cylinders, though, there's not a lot to say about them. We don't have any edges, we don't have any vertices because we don't have any lines that are connected. We're talking about a circle here and a circle here. Circles are different from polygons, but we are going to see again that a lot of the properties that we have for prisms will also be true for cylinders. Then we get to our slightly more complex shapes. Here we have pyramids. Now, you've seen the Great Pyramids of Egypt, and those, mostly look like the one that we have on the right side over here. Mostly they look sort of like this, but you could have a pyramid that's like this too. Now, we're back to a kind of shape where all of our faces, every single surface of this pyramid, is a polygon, is some sort of shape that only has straight line edges. The difference now is the number of bases that you see here. Now, pyramids only have a single polygonal base, and we'll get to which one of those faces it's going to have to be here, but take a note of the second piece. The lateral faces of a pyramid are triangular. If we think about this the same way that we heard with prisms, then the base of your pyramid is whatever shape is not a triangle. So, for this pyramid over here, we again name pyramids the same as prisms based on the shape of their base, and so we have a pentagonal pyramid. Over here on the left, or sorry, on the right, those great pyramids of Egypt, most of them have square or maybe rectangular bases, but if it's a square, we call it a square pyramid. So again, you see a little bit of things that are in common with prisms, but now we're talking about triangles for all of our lateral faces. Everything in this pyramid that is not a pentagon is a triangle. These three surfaces in the front and the two surfaces that you would sort of have in the back of that. And seeing like what's front and what's back of our three-dimensional solids, especially if you try to draw these yourself, can be very challenging, but hopefully with practice we'll get it down. And that brings us to the last type of 3D solid we'll be talking about today, at least introducing, and that's a cone. Now, cones sort of have some properties in common with cylinders, just like pyramids had properties in common with prisms. Each cone, no matter whether it's an ice cream cone this way or a party hat or whatever you want to call it, they have a single base which is circular. So, yay, one circle that makes up this base. And then it has only one other surface. Again, think of an ice cream cone. Okay, you've got the circular piece up here. The rest of the cone is just one solid mass. And that second face of your cone is actually going to be a sector. It's a piece of a circle. So we're going to see that in just a second. But here are 4 main types of shapes that we'll be focusing on in this unit. We'll talk a lot about prisms. Cylinders, maybe less so because, you see one, you've seen them all. Pyramids, of course, have a lot of different properties we'll talk about, and cones, they can be a little bit weird, maybe a little bit more complicated than cylinders, but we're going to see that they have a lot of things in common with one another. All 4 of these shapes have a lot of things in common with one another, and we'll be able to use that to our advantage. So, to end this PDF that I've sent you guys will see that I have this at the end here where it says we can take any 3D solid shape that we have and unfold it. Basically, we take our box and imagine you've just gotten a box from Amazon, you break it down so that you can recycle it. And when you break it down, you'll see something that's like this because now it's flat. It is a 2-dimensional object. We call these the nets of our 3D solids, taking our, in this case, rectangular prism, unfolding it so that you see the, 1, 2, 3, 4, 5, 6 different faces of that prism as 2-dimensional objects. So now you can see all of the rectangles that make up this rectangular prism. It gets a little bit more complex as our shapes get more complex. We've got a cylinder here. Well, we said that a cylinder is made by taking a rectangle and essentially wrapping it into a tube, but we can't forget that we have 2 other surfaces here when we unfold it. So, yeah, if your top and bottom aren't hollow, you would have those circles that need to be 2-dimensional objects when we flatten it out. Down here in the bottom left, you guys will see a cone, and like we said, whatever is not the base of your cone, so not the circle, is a part of a circle. You have a sector here. Now, remember what we knew about sectors, it's some fraction of the circle. So if you really wanted to know something about this sector, you'd have to know how many degrees a certain angle is, like this one right here. And that can be a little bit complex, especially since that angle is larger than 180 degrees. We won't thankfully deal with nets of cones very often, but it's nice to see that they exist. Over here, before we begin, ladies and gentlemen, what kind of shape is this? I'll give you 5 seconds before I ruin the surprise. Well, you have a shape that is made up of a bunch of rectangles, and the only other 2 bases that you see here are pentagons. So we would call this a pentagonal prism. But you can see the same way. When we unfold that thing, if we have a top surface and a bottom surface, yeah, those 2 pentagons will be part of it, and everything else, every other rectangle that we see there is going to show up. Now, to end this, overview of what these kind of things look like, I would like to point out there's a lot of different ways that we could have drawn these things. I happened to attach all of the rectangles to this one pentagon and left the other one mostly blank. I could have split some of these between the sides just as long as, I could have taken this shape and put it over here maybe. For the rectangular prism, I could have had a different shape as this one in the middle. It could have been this. This rectangle would turn a little bit. This rectangle would turn a little bit. But I think a better way to show you guys is to actually show you when you have three different nets here that can all fold together to form the same shape. So again, here you see a hexagon inside this thing. Sorry. Here you see a hexagon inside this thing. You see a hexagon in the middle here. You see a hexagon down here. Every other face that you see, every other two-dimensional object is a triangle. And whether you split all of those triangles off of the same hexagon, whether you put that hexagon on one of the triangles and fan them out, whether you put it on one of the triangles that's, on the left or right sides and fan them out this way, they'll all still fold together to form the same shape. A hexagon at the bottom, and every other face is a triangle. Since our lateral faces are triangles in our pyramids, we would call this a ... hexagonal pyramid. Yeah, the words pentagonal, hexagonal, octagonal, if we ever get there, they can be a little bit weird to hear because you're so used to saying octagon and pentagon. But again, with practice and with hearing me butcher the names over and over again, hopefully you'll be a little bit more confident. So that does it for our overview of these 3D solids. You guys are going to have homework in the form of a Google form attached to this same classroom post as you see this video and the PDF attachment. It's just going to be naming shapes. So I will give you a drawing in some cases, and you'll have to say, okay, what kind of 3D solid is this? You'll have a drop-down menu, so you won't even have to type anything in. Just select, in this case, rectangular prism, or even square prism would work for this too, right? If this is a square for your top and bottom, then yeah, we could call it a square prism too. So you'll have a few questions that say, okay, what kind of shape do you have here? And you'll also have a few kinds of questions where I give you the net of a shape and ask you what it would fold together to give. So if you saw something like this, broken down box from Amazon, for example, you would say that it is a rectangular prism. And we can't say square prism for this, notice, because none of these are squares. So again, 10 questions on that Google form is the only assignment that you have based on this. Next lesson, we're going to start talking about finding the surface area and volume of all of these things, the sort of calculations that you sort of think of when you first think of a geometry class. So congratulations, we're finally getting to the geometry portion of geometry. Take care, guys. Have a great day.